Hi, this is Ms. Perez, and I'll be going over polynomials when a is greater than 1. So in my last video, I went over factoring a polynomial when a equals 1. So that looks something like this: x squared plus 6x plus 5. That could be an example where you see there's no leading coefficient here. So if there's no number in the front here where the x squared is, that means the leading coefficient is assumed to be this invisible 1. Okay, so that means a is equal to 1. Oops, sorry. A is equal to 1. And there's a set of steps you go through to factor it if this is the case. Now, if the a is not equal to 1, then there's a different set of steps that you need to take to factor the polynomial. And that's what we'll be doing today. So we're going to get a polynomial in standard form that looks like this: ax squared plus bx plus c. And we want to factor it in factored form. Okay, so that's our goal. And I am a big advocate on writing down directions in your notes, very clear directions, because certain problems require certain kind of answers. Sometimes you're not looking for maybe factored form, maybe they're looking for something else. So pay attention to the directions, and most importantly, put the directions in your notes. So if you're writing this down, I encourage you to get a sheet of paper or your notebook and put this example in your notes. Directions. So example: factor the polynomial. So in the previous video, there were 3 steps. It was very quick to factor a polynomial when a is equal to 1. Now you can see here that I have 8 steps listed, and that might seem daunting to you. You're like, oh my goodness, 8 steps. But what I did here was I just broke it down really, really finely. So these steps aren't hard. They're actually very simple. It's just a lot of them, right? Because I've broken them down piece by piece. So they're not hard steps, and if you go through them one by one, you'll see that, and you'll be able to do this just fine. So let's go ahead and do that and get started, okay? So step 1, identify A, B, and C. And I'm just gonna, on the right-hand side, I'm just gonna kind of rewrite it. You can see it each step underneath another. Okay, so I'll do that right here. I'll start up here. There we go. Make this a little bit smaller. There we go. Step 1, identify A, B, and C. So we do this, mostly I do this so you can see, okay, this is the route I need to take. So you get to see, okay, A is equal to 4, which is, greater than 1. B is 14, and C is 6. Okay, so I always do start this with step 1, just so you know which method you're going to be using, because there's different methods of factoring depending on the characteristics or the situation that you're given. Okay. All right, step 2, it says factor the GCF if you can. And I have a large if here because sometimes step 2 can happen and sometimes it can't. If you have something like this, 7x squared plus, 5x plus 3, well, none of these numbers have a multiple in common, so we can't pull out a GCF. So we wouldn't do step 2, we would skip to step 3. But you definitely want to include step 2 in your process so you can just double check that. Now, in our case, we can pull out a GCF, so I'll have you take a look at that and think about what we're going to pull out. Okay, now some red flags should be going off because all three numbers are even. We have a 4, a 14, and a 6. So if they're all even, at the very least, you can pull out a 2. And in this case, that is the greatest common factor. Sometimes when you have even numbers, that isn't always the case. You'll be able to pull out a greater multiple, but for now, for this instance, the greatest common multiple is 2. Now, when we factor out a GCF, essentially what we're doing is dividing. That's how we pull it out. Okay, it doesn't just magically come out of the polynomial. What you're doing is you're dividing. Okay, so when you find the GCF, you put little division sign in each term and then divide that greatest common factor out. And another thing I want to note is that you not only have to look for a multiple of the coefficients, but you also have to look for variables. So you have to say, okay, do they have any variables in common? Well, these two have an x in common, but this guy doesn't have anything. So we cannot pull out a variable unless all three terms have a variable. Okay, but if they do, all three have the same variable, then you can pull out, a number of them. Okay, so back to this. So when we pull out a GCF, we are essentially dividing. And when we divide by our GCF, it pulls it out of each term. Now, when we pull it out, it doesn't magically disappear, okay? Remember that. When you pull out a GCF, it doesn't magically disappear. It actually ends up on the outside of the parenthesis, okay? So like I said, we are dividing. So when we do divide, we do 4x squared by 2. It's just 2x squared. And if you need help on this division process, let me know. We'll during session. 14x squared, that's 7x. And 6 divided by 2, that's 3. So everything left, so we pull out the GCF, it goes on the outside of the parenthesis, and what is left over is what after we divide, that's what's left over. Okay, now I will say some students get problems like these wrong because of this guy right here. Once we pull him out from step 2, nothing happens with him. He just kind of lingers around. He just chills out outside those parentheses the entire 8 steps. Okay, and a lot of times he gets lost in translation. So please don't do that. Hold on to him, keep bringing him down to each step, with you. Just keep dropping him down. He's just going to chill out there. He's not going to do anything, but he does need to get brought down. Otherwise, the 2 magically disappears, and we don't want that. Okay. All right, let's move on to step 3. We've, pulled out the GCF and simplified. So let's do step 3. Step 3, multiply A and C together. Now, I will mention that the A and C I want are from this new version, right? So let's go ahead and rewrite that. Remember, we're dropping that 2 down. Okay, so now we have our new A, B, and C. So let's just go ahead and A equals 2, B equals 7, and C equals 3. And how I know what A, B, and C are is from the standard form. I'm kind of just matching up everything, right? The 2 is being multiplied by the x squared, so that has to be my A. The 7 is being multiplied by my regular x, so that must be my B. And the 3 is just a constant out here with no variable next to it, so that's my C. Okay. Okay, so now that I've done that, let's go ahead and do step 3. Multiply A and C together. So my A is 2 and my C is 3. So that gives me 6. Okay, that's what I get. All right, so let's move down here and we're going to do step 4 now. So step 4 says, find the factors of step 3 that add up to B. So that's a funny sentence, but let's break it down. Let's just break it down one piece at a time. Find the factors of step 3. Okay, we're just going to do that. Step 3, the factors of 6. So, right, this is our number we got from step 3. So what are the factors of 6, right? Well, we got 1 times 6 is 6, and we got 2 times 3 is 6, and that's it. Now, sometimes you're not going to get this lucky. You might get a number like, 56, and this is going to be a long haul of things, right? It's going to be 1 times something, 56, and so on and so on, 3, 4, 5. You might have to list, quite a few numbers and factors here. I list them out just so I can visually see them. I'm a visual learner, and especially if you're not as familiar with your multiples as you'd like, then yeah, listing them out is going to be a great option for you. Okay. All right. So next step. So if we found the factors of step 3, now the second part of this is that add up to B. Find the factors of step 3 that add up to B. What does that mean? Well, B equals 7. So we have to find the factors that add up to 7. And this is pretty easy if we just kind of look at it. We could manipulate these, positive and negatives to get what we need, but in this case, we don't need to. It's pretty easy. If we added 1 plus 6, right? If we added these two factors, or these two multiples, we do get our 7. Boom. So that's good. Even if, let's just pretend like we didn't what we wanted. If we did, 2 plus 3, well, that doesn't work out, right? It's 5. So we can't use that. So that's kind of how you're going to do the add up to b part. Okay, so step 4, we found the factors that add up to b, which were 1 and 6, right? 1 and 6 give us 7. So this is what we're going to be using, or the 1 and 6 part anyway. All right, 1 and 6. Okay, so let's go to step 5 now. Okay, step 5, replace the b term with the multiples found in step. All right. So replace the b term with the multiples found in step 4. Okay, so let's rewrite our problem from before, right? 2 times 2x squared, oops, plus 7x. Let's see what this last part was. Plus 3. Okay. Plus 3. There we go. Okay, so now that, and I encourage you when you go through each of these steps, continue to rewrite the problem before you do work on it so you don't confuse yourself. And notice I still have my, it's lingered out here. He's not going anywhere, so just remembering to drop him down. Okay, so replace the b term with the multiples found in step 4. Well, in step 4, the multiples we found were 1 and 6. So we're going to replace our b term, which is 7x, the middle one. B is the middle term. Let me make those arrows just a little bit longer. Okay, if we replace this with a 6 and a 1, you can kind of see that we haven't changed the value of the equation, right? 6x plus 1x. 6x plus 1x is a 7x, right? So we haven't changed the value at all. It's still the same value. 6 plus 1 is still 7. So we took the multiples from step 4, right? And we replaced our b term with them. Okay, so everything else needs to stay the same. So we're just going to drop everything else down. Don't change nothing. Okay, and that's a really important concept for you to understand, is that a lot of times we need to manipulate an equation to get what we want, but we don't want to change the value of it. Okay, so we just changed the way this polynomial looked, but we did not change the value of it in any way, right? We still have a 7x here. Okay. I just wanted to make that clear. So let's go ahead and move on to step 6, which is group the first two terms together and the last two terms together. What does that mean? Well, let's move down a bit. Oops. There we go. Okay, so again, this guy's going to stay out here. All right, and and you notice I'm rewriting it exactly the way it was from the step above, right? I'm gonna rewrite it from the previous step, and then I'm gonna work on it. Okay, so my first two terms are 2 and 6, right? And then the next two terms are x and 3. Now, if you forgot, terms are separated by pluses and minuses. So I could have a, for example, let's just go an example, xyz squared plus 3y minus 16zx, or zy, zyx, well, I don't know, zyz, whatever it is. So in this case, this is a trinomial. I know it looks a little funny, but it's a trinomial, right? There's one term, there's the second term, and there's the third term. And how do I know that? Well, they're separated by pluses and minuses. All this stuff in here, this is all multiplication and exponents, right? These are all grouped together. This is all multiplication. 16 times z times y times z. This is all one term. This is all one term, and this is all one term. So just a little refresher on how to establish how many terms you have. Okay, so I'm grouping my first two terms with my last two terms. Okay, so let's go ahead and do that. I have 2x squared grouped together with the 6x. And I have my x plus 3 grouped together. So now grouping, the word grouping just, means put parentheses around. Okay. All right. So let's go ahead and move on to step 7. All right, let's go ahead and move down. So from this, we are going to factor GFC from each set. So let's go ahead and do that. And again, I'm going to keep my 2 right here on the outside, right? It's being multiplied. I'm going to rewrite it just the way it was. And then I'm going to work on this. Okay. All right, so let's look at the first set. We'll just look at the first set, just the 2x plus, 6x. Missed the x. There we go. Okay, so let's look at that first set. What do these two have in common? What multiple do they have in common? Do they have a variable in common? So the common multiple is 2, right? Easies. They're both divisible by 2. Now look at the variable. Do they have a variable in common? Well, yeah, they do. They have an x. Can we pull out an x squared? Well, no, we can't pull out an x squared because this guy right here doesn't have an x squared, right? And a little thing about squares, x squared means there's 2 of them. There's 2 x's being multiplied. So that's how many this term has, okay? This term, on the other hand, only has 1 x. So we can't pull out 2 x's because there aren't 2 x's in each term. So you want to pull out the, at least amount of variables you can. So at least we can pull out a single x from both because they both have at least a single x, okay? All right, so let's do our thing. So this guy gets dropped down because we don't want to lose him, right? Remember, don't want to lose that guy. Okay, now let's actually do our factor out the GFC. So remember, when we're factoring out a GCF, we are essentially dividing. And when we divide out a GCF, it does not magically disappear. Where does it go? On the outside of the parentheses, right? And everything else that's left over goes on inside. So let's do this. 2 divided by 2 is 1, so those cross cancel. X squared divided by x is just an x. And if you want a little refresher on that, x squared divided by x looks like this, right? X squared is just an x times x. Now we have an x right there. And then now we can cross out at least a 1x. And what are we left with? Single x, right? Okay. Hopefully you're pretty familiar with variables and exponents, dividing them. I think that was in the tutorial before. Okay, so we got an x. All right, so now let's do 6x divided by 2x. So 6 divided by 2 is 3, and x divided by x is 1. So we're just left with x plus 3. I could actually move this parenthesis over just a tad. There we go. Okay, so now let's do the next one. Let's make these brackets. We'll just bracket this guy. There we go. Okay, so do x and 3 have a greatest common factor? Do they have anything in common? Do they have any multiples in common or a variable? Well, no, they don't. And that's okay. So we're just going to, just for of the I, we are going to divide by 1. Okay. You don't need to. You could just drop down the x plus 3 if you want and just know that there's an invisible 1 in front. But for those of you that need a little extra visual help, like me, let's go ahead and do it this way. So we're going to divide by 1. We're pulling out a 1, the greatest common factor, which is, 1. And it doesn't disappear, so it goes in the front, and everything else gets put inside the parentheses. Now, remember, anything divided by 1, like 100 divided by 1, -5 divided by 1, anything divided by 1 is itself. So 100 divided by 1 is 100. -5 divided by 1 is -5. So anything divided by itself, oh my goodness, I'm sorry, I didn't mean to say it that way. So anything divided by 1 is itself. 100 divided by 1 is 100. -5 divided by 1 is -5. Okay. My whole feel about that. The reason why I'm saying this, because x divided by 1 is still x, and 3 divided by 1 is still 3. Okay, now I'm going to make a huge note right here. When you reach step 7, this is really crucial point in the process, and I'm going to put, like, big stars here. Okay, and I'm going to change this, maybe to purple, and make it bigger. There we go. Okay, and so at this point, the thing in the parentheses has to be the same. Okay, so notice we have an x plus 3 and an x plus 3 in the parentheses. That's good. Good thing. If they're not the same, then something went wrong. Okay, and we have to go back and check our steps. So we want these two things to be in the parentheses the same. And the reason being is because on step 8, we're going to pull out the GCF again. Okay, remember that when we pull out a GCF, we're looking for the greatest common factor. And if we look, these two pieces, this is all one big long term, and this is another big long term. So we only have 2 terms in here. So we're looking at this thing and we're going, okay, what does it have in common with the other term? What can we pull out? What is the greatest common factor? And you'll have to, be able to look at this and go, oh, okay, well, x plus 3 is the greatest common factor. Okay, so this is all being multiplied together, right? 2 times 2x times x plus 3. 1 times x plus 3. Okay, so the greatest common factor for step 8 that we're going to be using is x plus 3. And I know you're saying, oh, terms are separated by pluses and minuses, and this is, this is my plus, this is how I'm separating them, right? I'm saying this term and this term is by a plus and a plus sign. And you're like, hey, Miss Perez, well, what about these signs? What are those? Those chopped liver? Well, think of parentheses as like magic shields. Okay, so this is 2 times 2x times something in the parentheses. Anytime you see parentheses, those are magic shields, okay? And this is 1 times, something in parentheses. But this is multiplication, okay? Inside the parentheses as a magic shield, and those pluses or minuses don't count in terms of finding the how many factors, or sorry, how many terms you have, okay? This is all multiplication. This is 2 times 2x times, something. And then this is 1 times a big something. So parentheses are magic shields, okay? And they don't think of them as using defined terms, okay? So hopefully that's a little helpful as to why. Okay, and if not, just know the thing in the parentheses is the GCF for step 8, and we are going to be pulling that out. So, and I'll actually write that for you. Okay, oops, not purple. Okay, step 8, again, factor out the GCF, aka the thing in the parentheses. So again, I'm going to rewrite what I already have before I start working on it. So right now, what I had from the last step is the 2, the lonely 2 that hasn't done anything since we pulled it out in step 2. That's still hanging around. My 2x times magic shields, x plus 3, plus 1 times x plus 3. Okay, so step 8, again, factor out the GCF, aka the thing in the parentheses. So it kind of just tells you exactly right there what to do. Okay, we are going to factor out an x plus 3 each term, and we only got 2. Okay, now when we do that, it's just like anything else. So see this arrow that dropped it, down here, doesn't magically disappear. So when we factor out a GCF, we are dividing, and it does not magically disappear. It goes on the outside of the parentheses. Now, since we're factoring out 2 terms, or not to be confusing, but since we're factoring out 2 pieces like this, we are going to put parentheses around it. Okay. So we're going to factor out the x plus 3, and it does not magically disappear. It goes, drops down, and it goes on the outside of the parentheses of what's left over. So, and then I'm going to go ahead and drop this 2 down here before I forget about it, right? Remember, he just kind of lingers. Okay, so when I'm dividing x plus 3 divided by x plus 3, those cancel out, right? Now, what is left over? Well, I got a 2x left over and a 1 left over. Okay, so let's put that in there, 2x plus 1. Okay, and now I'm in my factored form, pretty much as much as we're going to get, right? So this is my answer. Yay, us. So after 8 steps, this is what we get. Okay, now notice the 8 steps aren't super difficult. There's just a lot of them, right? And you just have to go slowly and, do each thing and make sure, everything's squared away. But I mean, they're not hard steps. They're just a lot more than the 3 that was in the last video. So if you want to practice this, we have some extra credit worksheets available to you. Just contact a math teacher and they'll be happy to provide those for you. So if you want to practice your factoring, which I suggest you do, this is a big part of algebra, and especially in your next math classes, I encourage you to do it. So hopefully this video was helpful. Thank you.